As the Electrical Training Alliance moves into blended learning, it's important to highlight the immersive and interactive tools available to students. Given the dangerous work that electricians face, the importance of going through simulations of real-life situations cannot be overstated. Lives depend on safety training, and simulations can play a critical role in this training. The following samples illustrate how interactive simulations can go a long way towards empowering the training classroom. Here is the dry-type transformer trainer. This simulation lets the user wire the transformer in both real-world and schematic views. Each view is in sync, so changes made to one occur in the other. In the real-world view, the user can manipulate the screen to reveal the look and feel of the environment from any angle. The user can verify circuit conditions by taking readings with a voltmeter. The simulation lets the user properly and improperly wire the transformer, and the consequences are immediate and free of any potential for injury to persons or property. Here in the Electrical Safety Simulator, the user is able to conduct a large variety of arc flash simulations by adjusting the many parameters of what could be a real-life situation. All of the fault circuit conditions are based upon the real-world calculations from the IEEE 1584 standard. In the Fluke Electrical Theory Simulator, the user can create circuits, energize them, and take meter readings to verify the conditions within the circuit. The online module recreates the resulting circuit parameters to allow the student to better grasp the functionality of any electrical circuit that they can imagine. Similar to the transformer trainer, there is the option of theoretical view or field view, which allows students to correlate theory drawings with real-world installation requirements. In the Fluke Instrumentation Academy, the learner becomes acquainted with the equipment and processes necessary when calibrating a device. As part of this process, he or she must properly complete the calibration data form. In the Salisbury modules, including effective cover-up, personal protective grounding, and care and use of rubber gloves, safety is the primary topic. For the effective cover-up module, the user is shown both correct and incorrect real-life simulations. The user is given choices of equipment to apply, and they receive immediate feedback on their choices. Quiz questions keep them on target as they assess their comprehension at the end of the module. In the Personal Protective Grounding module, the user gets to view information that can't be shown in real life. These simulations offer a deeper understanding of grounding and how it works behind the scenes. In the selection of insulating rubber gloves, the user learns about the types of rubber gloves and proper applications. They get to see if their choices work and what are the potential results. Their knowledge of what they've just learned is assessed throughout the module.
Welcome to the NJATC Test and Measurements Academy.
With the introduction to the Milwaukee Test and Measurements Academy, the user becomes acquainted with the tools needed as well as the three-dimensional first-person interactive simulation present within the Academy.
To do this, it's highly recommended that you use a mouse.
In the work order portion of the Academy, the user is challenged by troubleshooting in a real-life environment. Users are given the work order, a selection of personal protective equipment, the floor plan, and diagrams. The user must then walk through a building to try and resolve the issue presented by the work order. Once again, the user is presented with correct and incorrect options to learn the proper and safe use of electrical test equipment. In the Klein Virtual Bootcamp, students are presented with simple tasks like installing wiring devices. In doing so, The user gets to examine and select tools using three-dimensional views. Progressing through this module, the user gets an intimate view of how to wire a receptacle using 3D animation. In the Basic Hand Tool and Identification and Use module, the user becomes acquainted with many of the hand tools of the trade. 3D modeling helps the user view each tool as if they were picking it up themselves. The module also acquaints the user with the materials used in the trade. Educating the user on the tools and materials will give them a realistic understanding of what to expect on the job site.
The term ground is defined as the earth. Electrical systems are connected to the earth to minimize...
The Thomas & Betts Grounding and Bonding Academy uses online interactive content to assist learners through one of the most misunderstood topics in the electrical industry. One module covering the grounding electrode system educates the user on the theory and proper assembly of a grounding electrode system. Throughout the program, the user must answer questions to make sure they are learning the pertinent information before proceeding further.
The equipment grounding terminal buses of the normal and essential branch circuit panel boards serving the same individual patient care vicinity must be connected together with an insulated continuous copper conductor not smaller than 10 AWG. Bonding all equipment grounding conductor terminal bars of all panel boards serving the same patient vicinity helps minimize the possible potential differences.
In the module 3M single-phase circuit numbering, the user learns about phase relationships and color coding on single-phase panels. The goal of this lesson is the ability to identify conductor, color, and phase relationships.
The NEC provides guidance for determining circuits in a room from a set of drawings. It is necessary to review the basics of reading power and lighting plans.
In the 3M module on identifying circuit conductors derived from blueprints, the user is educated on how to understand the wiring of a circuit or circuits by reading blueprints. By testing the user, the module ensures that the user properly comprehends the lesson. In the Milwaukee Conduit Bending Simulator, the apprentice is introduced to the different formulas needed to make the correct bends when practiced in the lab. In the Greenlee Conduitbending Best Practices module, the apprentice is introduced to the different types of conduit and common errors to avoid. In this Greenlee Concentric Bending exercise, students explore how conduit size, spacing, quantity, and the number of bends affect concentric bending as variables are selected from drop-down menus in the program. In the Prismine Group module introducing medium voltage cable, the student learns about the different kinds of cable and fault types experienced with this type of cable. In the 3M cable splicing module, the apprentice is shown the methods used when splicing cable. Becoming well acquainted with the process before actually performing hands-on can save time and material in the classroom environment. In the Schneider electric motor control simulator, students have the ability to pick the appropriate components, examine them, place them into appropriate locations, and wire them into a functioning circuit. The student has the immediate ability to understand how their circuit functions. This Southwire installation design module demonstrates the parameters entered into a spreadsheet application used to calculate elements of the pull. The goal of these and future modules is to empower the classroom so that, in turn, apprentices and journeymen empower and impact the industry. With the constant changing demands of electrical work, these simulations offer another important tool to help the Electrical Training Alliance meet the ever-changing and growing needs of the electrical industry.